Alright, so it's dilations notes. Before we even start talking about dilations, I want to go track back for you a little bit. When we was in Unit 3, transformations, I told y'all that there was one transformation we weren't going to do in that unit. And this was that one, dilation. A dilation is a transformation. So the three transformations y'all know so far are the translation, rotation, and reflection. We did all those three together in that unit because all those transformations were rigid transformations, or rigid motions. Meaning when we turned, flipped, or slid the image didn't change in shape or size. It stayed congruent. On this one, with the dilations, when we dilate a figure, the size of the figure changes. The shape doesn't, but the size changes. We enlarge it or we make it smaller, which is called a reduction. That being the case, this is not a rigid transformation, and we didn't do it in that unit. We're doing it in this unit with similarity because it kind of goes with similarity. When you dilate a figure, you're creating a similar figure. The shape is going to look the same. It's just going to be either smaller or larger than the shape you had before. So that's why we do this transformation in this unit. But this is considered a transformation. But this is the only one that doesn't keep figures congruent. They're just similar. Alright, so that's my little quick intro. So similarity dilation notes. At the beginning it says the dilation is the enlargement or reduction of a figure. Enlargement or reduction. It's a fancy way of saying, or geometrical way of saying gets bigger or smaller, but we're going to say it's enlargement or reduction. The scale factor, which we learned about yesterday, indicates how much the figure will enlarge or reduce. The variable for scale factor is the lowercase k, and just so you can see it, it's down here in your examples. K equals 2, that's my scale factor. K equals 1 over 4, that's my scale factor. When K, which is my scale factor, is less than 1, then the dilation is a reduction. If my scale factor is less than 1, then my dilation is a reduction. Anything less than 1 will look like a proper fraction. A proper fraction will look like 1 over 4, 2 over 3, 3 over 4, 1 over 5. Anything like that where you got a fraction in your numerator smaller than your denominator, that's a proper fraction. That's going to be a number less than 1. That's going to be a reduction of your image. When K is greater than 1, the dilation is an enlargement. An enlargement will be pretty much any whole number greater than 1. Also, it could be any improper fraction, like 5 over 2. That's going to be an enlargement. 5 over 3, 4 over 3, 3 over 2. All those improper fractions will be an enlargement because your number on top is bigger than one on the bottom. If you think about it, 3 divided by 2 is 1.5, so that's something greater than 1. Yeah, if you don't mind. Symbolic forms. Never really see this form, but we do use this form for actual K. So it's a transformation where K times X, comma, your K times your Y. It's you multiplying your scale factor by both your X and Y coordinate. Which you also see in what kind of way of dilation of K, whatever your scale factor is, and we'll say equals whatever. Alright, so that's the notes part of it. Let's do some dilations. graph and label each figure in its image under the given dilation. The first one, number 1, says triangle RST with vertices R, -5, 1, S, -3, 4, T, -2, 1, and with a scale factor of 2, K equals 2. So first we want to graph this image, pre-image, excuse me. -5, up 1, -3, 4. Come on, I'm back. Alright, so this is your figure. Graph RST. We're going to dilate this by a scale factor of 2. To dilate, what I want you to do, and we saved y'all space out here. We didn't do this on your practice. You're going to find space in your practice. Now to the side here, I'm write R, which is my original coordinate, but I'm going to gap it out. I'm going to say some space in between. I'm going to say -5 space. Give myself some space, 1. These coordinates are already written at the top for me, so I'm just pulling them from the top. I ain't getting these from no magical place. S, -3 space, comma 4, another space, then T, 2 space, comma -1. Let's write my coordinates from the top. I'm about to dilate. Dilate is easy. Dilate, all you do is multiply your coordinates by the scale factor. Scale factor for this one was 2, so times 2, times 2, times 2, times 2, times 2, times 2. Everything, X and Y, gets hit with a times 2. So on this one, my new R prime would be at -10, +2. S prime would be at -6, +8. T prime would be at 4, -2. After I do the multiplication. And from there I'm graphing that. -10 up 2, R prime, -6 up 8, S prime, T is at 4, -2, T prime. Did it right, your image should look like it got larger, and should look like it doubled in size. So this is my image after dilation with a scale factor of 2. Things that I will say that I want you to know. So these figures, they're similar. So the shape didn't change, only the size did. Since they're similar, when you're doing dilation, the similar or the corresponding sides will be parallel to each other. So like ST and S prime T prime, these two sides are parallel. RS and R prime S prime are parallel to each other as well, and then RT and R prime T prime are parallel as well too. And the other thing you should notice too, these dilations that we're doing on the front are about the origin. They're from 0, 0. That being the case, the larger your image gets, the farther away it's going to move from 0, 0. It's going to stretch out further and further away from 0, 0. The smaller your image gets, the closer it's going to get to 0, 0. So if we would have reduced this first figure, it would have got closer to being inside this figure, and it been closer to even closer to 0, 0. You'll see even on the next one. On the next one, our scale factor is 1/4. So our image is going to shrink. The image that we make is going to get closer to 0, 0 than the original image. Alright, so let's do this one. Triangle WXY, graph it. -4, 8. -10, 0. -2, -8. So this was W, X, and Y. That should be our image. Down here, I'm going to just take my coordinates up here, write them down here with some space in between them. So my W, -4, comma, 8, yeah. X, 10, comma, 0, and then Y, -2, comma, -8. And from there, using my scale factor, which was 1/4, so I'm timesing by 1/4 everything. 1/4. And you may need a calculator for this one. Shit. I don't want y'all to overcomplicate this. You times in a whole number times a fraction. Anytime you do that, it's easy just to understand that since it's a whole number, you don't have to put it under 1. You don't have to do all that, make that a fraction. It's a waste of time. Understand that top number is going to be multiplied by that. I mean, the whole number is going to be multiplied by the numerator on the fraction, and then you're just going to divide by the denominator. So for the first one here, it's going to be -4 times 1, which is -4, divided by 4. -1, right? Yeah. The Y value is going to be 8 times 1, which is 8, divided by 4, 2. And then here, so you may need a calculator here. 10 times 1, 10, divided by 4. You can give me the decimal. It's going to be 5. If you reduce it, it'll be 5/2, but we want the decimal. We got to graph it.
2.5?
Yeah, 2.5. And then 0 times 1 divided by 4, 0. -2 times 1. Say it a little louder. -0.5. And then -8 times 1 divided by 4. There we go. So those are our points. We got some halves on there, but you can graph a half pretty easily. Just got to make sure you're doing it the right way. I'll do it with you though. First one was -1 up 2. So -1 up 2 is right here. That's going to be W prime for me. Next one was positive 2.50. So count over to the right. 1, 2. 0.5 would be in the middle between the next line, so 0.5 here. So this is 2.5, and then I'm staying at 0. Let's put your dot in the middle right there. And then the last one is -0.5. So in the negative direction over 0.5, which is half. Here, and then down 1, 2. And this was X prime, this was Y prime. is your image after a dilation of 1/4. You see the image got smaller, and I told you the smaller it gets, the closer it's going to get back to 0, 0. Look how it's moving closer to 0, 0. This is our original here. The smaller image got closer to the origin. So that is graphing, I was doing a dilation from 0, 0. Should be pretty easy for y'all. All y'all got to do is multiply. The one that you may have a little bit of trouble with is the one on the back. Dilating from a point not on about the origin. But we're going to give you some rules for this. And we already kind of done something similar before. If any of y'all in here were good at doing the rotations from a point that wasn't at 0, 0, and we had to create our own axis and all that and rotate around it. If you were decent at that, you should be decent at this. It's similar to that, except we don't have to turn our paper. Alright, so dilation, not about the origin. First thing you want to do is find your horizontal and vertical distance from your center point. And you want to find that to one of the coordinate points on the pre-image. Then after that, multiply the vertical and horizontal distance k times, so by your scale factor. Based on your scale factor, you're going to multiply that vertical and horizontal distance. Then count that many units from the center vertically and horizontally. And then it says repeat step 1 and 2 for the leftover points. So, it's a bunch of words right now. It ain't going to make sense till we actually do it, of course, as always. So down here, graph and label each figure and its image under a given dilation. Number 3, quadrilateral math. So we're going to graph that, those points, and then it says use point P25 as the center, and then use a scale factor of 3. So let's worry about graphing it first. Math. 4, 2. Make sure you graphing, Reese. 0, 4. Negative 2, 2. And then H 2, 0. I just realized Earl ain't here. So that's my pre-image math. Other thing I need to put on here is my point, which is going to be my center of our rotation. So let's say that point was at 2, 5. 2 up, 1, 2, 3, 4, 5. So my point is going to be here. Like I said, as we've done before, I'm going to make an axis around this point so I can see it. I'm doing a highlighter for y'all. I'm going to draw an X and Y axis around this point. So that point is going to be my point of reference for my points that I'm about to find. So tell you what, before we even start doing that, down here at the bottom, That's just all we're gonna do is write the letters in parentheses. M parentheses A parentheses. Don't put no numbers in. You don't know the numbers yet. T parentheses H parentheses. Remember, this is different from the ones on the front. These are not around the origin, so we can't do it the same way. On this one, my dilation is happening from this point that I've made here, and I've made axes around it. So what I want to know is, where are these points M, A, T, and H from this center? So from this center right here, where will my M be? 2, -3. Anybody that don't know how we got that, ask now. And I'm writing that down here, 2, -3, with my space in between. The next one, A, where's that at? -2, -1. Make sure y'all see it. I wrote it down here too, I'm sorry. And then the next one, T. Say it one more time. Okay. T is at -4, -3. And then the last one, H. 0, -5. Our scale factor was 3. We're times them by 3. But don't try to go ahead of me. Don't do anything ahead of me because you're going to mess up. We're multiplying these points, but we're multiplying based on the points that we took from P. So we can't write these over here in this section once we get these numbers, because these aren't our actual locations of the points. These are just going to be our locations from point P. So we need to probably just write I'm going to just write above each one the coordinate that we get. So for the first one, it's going to be 6, -9. Second one, -6, -3. Y'all follow me? The next one is going to be -12, -9. And then the last one is going to be 0, -15. I don't want to put these over here because these are not the actual points. These are just the points from P. So I'm gonna go back up, use these points, and go from P and count my and put my new points on. So from P for M, I'm gonna do 6, -9. So from P, starting here, that's my 0, 0 for right now. Going over 1, 2, 3, 4, 5, 6 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. That point right there is going to be my M prime. And then going back to 0, 0, I mean my P, I'm doing -6, -3 next. So from here, -1, 2, 3, 4, 5, 6, -3 down, 1, 2, 3. This is going to be my A prime. And then I'm doing the T next, which was -12, -9. This graph is 10 each way, and I'm 2 over. So -12 would be all the way at the end over here. Here, -12, and then down -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. T prime. And then the last one is 0, -15. So 0, stay at 0, and go down -15. This is 5 right here. This will be my other 10 right here at the very bottom. here. This will be H prime. Then I want to connect. What you talking about? Alright, so once you get that image graphed, now the last thing you want to do is tell me my actual points. So where's my actual M, and you're doing that from the origin, the original origin, 0, 0. So you count the actual points from there. Where's M prime? A little bit louder. 8, negative 4. A prime. Negative 4, 2. T prime. Negative 10, negative 4. And the last one, H prime. Thank you. 2, negative 10. That's how you want to handle the one where your point is not around the origin. And since my point was up here, my center point, when I did my dilation, it got bigger. It moved further away from that point. If it was to get smaller, it would have moved closer to 0, 0. But since it got bigger, it moved further away from 0. Well, my center point in this case, which was here. We treated this as 0, 0 this time. What's up, Faye? Last one. And you can go ahead of me if you think you know what you're doing here. Only difference on this one is the 1/2. You're going to have some decimals at the end too, so I can get with you. You can, but setup is pretty much the same. You just got to put your points on, put center point on. Ten is all the way up in the corner. 5, 8. It's a little bit of a weird shaped quadrilateral. Make sure you going from the way it's named to draw your lines correctly. A to B, B to C, C to D, D back to A. So you should have not something close, you should have something looking like this. And then put point P on. Point P is at 3, negative 4. 1, 2, 3, then 1, 2, 3, negative 4. I know it's off. Nobody even correct me. You seen that? I started thinking it was going by 8s. I messed up. I'll redo it. I don't remember that dot being outside. On the inside. You was probably right, Reese. I drew one of my points, man. I can't even correct it on this. I'm gonna show y'all my other paper. It's smaller than that, yeah. This point right here is off. My bad, y'all. My point D was off. I did one -9. That's why we don't use pen. So you have to ignore that part of my drawing. Making my axis. So scratching that out. Right. So on this one, same situation. I was going to make room for my coordinates down here. A, B, C, and D. Now I'll read them off of here from my point. It's a lot of counting on this one because the numbers are big. Anybody got them? The points, yeah. A is where? Girl, the original. I mean not after you did the math. Seven and what? How about I say 7 and 14? Seven up 14. Okay, what about B? 212. We rolling with that? So -9, comma 2, and then D is what? -2, -3. Alright. So we multiplying by 1/2. So basically cutting everything in half. Seven times 1/2. 3.5. Can't write it over there. Gotta write it up here. 3.5, comma what? 7. And then 2 times 1/2, 1. And then 12, 6. 9 times 1/2, 4.5, or -9, so -4.5. 2 times 1/2 is 1. Then the last one, -2 times 1/2, -1. And then -3 times 1/2, which I got. Assuming -1.5. Sorry I'm writing those so small. I just don't want to put them anywhere else. It's 4.5 or -4.5. Alright, so we got to count those from there. It's like got decimals on 3 of them, but you can do it. So from the point A would be to the right 3.5, 1, 2, 3.5 in the middle, then up 7, 1, 2, 3, 4, 5, 6, 7. So here, this would be A prime. Like I said, you gotta ignore these other lines on mine, they shouldn't be here. And then B is at 1, 6 over 1 up 1, 2, 3, 4, 5, 6. B prime. And then C is at negative 4.5, 1. So to the left, negative 1, 2, 3, 4.5 up 1. Huh? Who? Oh, Nivea? Not here. And then the last one, he ain't here either. Dennis. Yeah, missing bodies. Negative 1 and then negative 1.5. So to the left, negative 1, then down, negative 1.5. Not here. Yeah, you better. You calling all the names. No problem. Yeah. And hold on, I'm almost done. Don't mess up the video. We can talk about it in a second. I'll give my points and then we good. What y'all say? 6.5 and what? 3. Alright. B prime. What's that? 4.2? Yes, no? Maybe. C prime. Alright. I see negative 1.5. That's what y'all see? Negative 1.5. Comma 3. Okay. And the last one, D prime. I agree with it 2. 2 what? Two what? Huh? Oh yeah, negative 3. Yeah. Y'all still ain't gave me D though. Thank you. Negative 5.5. Hey, you didn't do bad with it today. Y'all should be alright. Even after the story.